Okay, good morning, everyone. Thank you, Professor Ferro, for the introduction. I'm Daniel Suarez, and a PhD student from Politecnico di Torino, and I want to present this work in the influence of biochar inside cement paste and mortars specimens. First of all, I have to talk about the Portland cement context, in which every year more than 4,000 million tons of cement are produced, consuming huge amount of energy, mostly produced from fossil fuels, emitting 1 ton of carbon dioxide for each ton of cement produced, contributing with more than 5% of carbon dioxide emissions. Meanwhile, some alternatives are soft. For example, supplementary or alternative cementitious materials and manufactured nanomaterials, in which these materials have been used to improve the mechanical properties of cement-based materials or to improve the durability to obtain long-lasting structures. But the question is, we have only these cases, for example, like fly ash or silica fume or carbon nanotube. To answer this question, I have to first talk about the waste context, in which only in America, more than 30% of the food produced there is wasted, and they generate also more than 70 million tons of food waste. Here in Italy, Italy produces 20 million tons of food waste and 3 million tons of food waste. Why I'm talking about this? Because we are generating biomass. To solve this situation, this problem, biomass has been treated to produce energy, or it can be treated to produce energy, and there is a new problem, or maybe a solution, the biochar. What it is? What is it? Sorry. It's a solid material that it's produced after the thermochemical treatment of biomass to produce energy. And this process, should be, or the most common ones are pyrolysis and gasification, and has been used mostly in the agricultural sector, but several researchers have found that it could be used as a filler to, like silica fume, for example, to improve the mechanical properties of cement-based material. So we can use it in the construction. Why? Because it's a porous material with a large surface area that can absorb water. It's chemically stable inside the cement matrix, and it's made of carbon, more than 90% of carbon. So it's a carbon-based materials, like for example, carbon nanotubes or carbon fibers, not the same one, but it's a carbon-based material. But the most important thing is a waste, and we can use it inside the cement matrix to improve the mechanical properties, as I said before. And for going to the experimental part, we use Portland cement type 1, water, surplus plasticizer in the case of cement paste, standard sand for mortars, and biochar, of course. Specifically, we use 2 types of biochar. Borgotaro one, that is generated, both of them, are generated in Italy. Borgotaro was obtained through gasification process, and Neta biochar was obtained from pyrolysis. Both mixes were first to begin with the mixes. We first mix the biochar inside the water, and then the whole mixing process was complete of making 4 batches, beginning with 0% of biochar inside the mixes, 1, 2, and 5%. After 28 days of curing, we performed two tests: the 3-point bending test to evaluate the flexural strength and fracture energy, and the compression test to evaluate the compressing strength. In the 3-point bending test, we used a Japanese standard, and to the compression strength, we use the Union 196-1. Moving to the results, we can see how the biochar particles can improve in almost all the cases the flexural strength property of cement-based specimens and mortar specimens, being the case with when 2% of Neta biochar was used, arriving to an improvement of more than 80%. And in the case of mortars, obtaining almost an improvement of 10% more respect to the reference one. Moving to the compressive trend, the trend was more or less the same, reaching in some cases, for example, in the cement-based material, all the same percentage, the 2% one, reaching an improvement of more than 60%, and in the case of mortar, arriving to more than 50%. And the last part is the refractory energy. This could be the most promising results, because in the case of cement-based specimens, we reach more than double the capacity of the reference one, reaching more than 150% in the first stages, which means 1% and 2%, and more than 240% more for when 5% of NEDA biochar was used. And in the case of mortars, we are improving to 20 and 25% when 2% of 5% of NEDA biochar was used. It could be seen also that in overall, Bogotá BIOCHAR has now the same capacity to improve the mechanical properties as NEDA biochar could do. And this may be because by the process that we use to obtain the biochar. In literal, it's possible to see how the pyrolysis process could be a more suitable to obtain a biochar that can be used for construction materials. To conclude, we can say that employing biochar inside the cement-based material could facilitate a sustainable production, because we're using a filler material that is a waste in almost all the cases. We are conserving landfill space when we are valorizing the biomass due to carbon dioxide emissions, and we are improving the mechanical properties or cement-based materials that usually are fragile materials, and we can see in the refractory energy, we are improving the toughness of these materials. And of course, more future studies have to be performed to obtain more knowledge about this filler. Okay, thank you.